The problem statement from GATE Physics 2013 reads as follows. An electron is moving with a velocity 0.85 c in the same direction as that of a moving photon. The relative velocity of the electron with respect to photon is. This is a numerical answer type question with only one correct answer, and we need to find the correct one. But before we start solving this problem, let's have a look at some relevant concepts. So in this, on the left side you have a frame S. Let's say this is at rest. This is an inertial frame, and on the right you have a frame S prime. This is also an inertial frame because this S prime frame is moving at a constant velocity v in positive x direction with respect to the frame S. And let's say there is a particle here, this particle P here, which is moving in some velocity ux in positive x direction. And what we want to know is we want to obtain the ux prime. We want to obtain this velocity, that is this same particle I denoted as P prime. When it's moving in this frame, let's note its velocity as ux prime. Note ux prime is the velocity of this object P with respect to the frame S prime. Just like the velocity ux was the velocity of this object P with respect to frame S. So I repeat, the velocity ux prime is the velocity of this object P in frame S prime. Now, how do we obtain this entity velocity dx prime over dt prime? We can simply obtain delta x and delta x prime and delta t prime. And how do we do that? We do that using Lorentz transformation. We know all the information about this particle in this frame, right? We know all the x and t, so we can simply obtain the prime entities. So what I mean is that we know delta x prime is x2 prime minus x1 prime, and we just put this formula over here. Similarly, delta t prime we can obtain like this, t2 prime minus t1 prime, and you use Lorentz transformation to get that. And now we simply but this is not in the when we put the limit delta x and delta t go to 0, so this gets converted to a differential, and we can simply now say ux prime is dx prime over dt prime. And if you do that, if you try to divide these two entities, and so a few terms gamma gets cancelled and whatnot, and you obtain this formula over here. And this is the formula that we get, that the velocity of object P in S prime frame is given by this entity, right? Let's get back to our problem that we had here. Before we start solving this problem, it's important to do some pre-checks. So we'll check what are the frames here. So I'll draw first my frame S. This is my rest frame, you can say. This is the frame where I saw that an electron is moving and a photon is moving, right? This is the frame where I saw that. This is the rest frame. This is 0.85 c, and this obviously will be moving at c. Now the question says that relative velocity of electron with respect to photon. This means now we have to go into a frame of photon. So this is a photon frame, so I call this the photon frame. If this is a photon frame, this photon frame will be moving at a speed c, because photon moves at speed c. So electron will be moving at some speed, again let's denote it by ux prime. This is our electron here, right? So this is my frame S prime, this is my frame S. Now since frame S is at rest, so S is inertial naturally. And what about S prime? S prime is moving at a constant velocity c, so S prime is also inertial. So second thing, we check with the moving frame what is the speed and direction. So this is a frame of photon, so speed would be c, so v I can write as c. And the direction, it's only a one-dimensional picture, so I can take this to be positive x-axis, so direction would be I cap. Finally, number of dimensions, the question is silent about how many space coordinates do we have. This is a very simplistic problem. Without loss of generalization, I can assume it to a one-dimensional system, in this case only the x-axis. Now this is the same picture I have reproduced here. So this is a rest frame, okay. This is my rest frame, and on the right you can see the photon frame. So this is moving at a speed c, denoted by S prime. And so in the green you can see photon denoted by P, so it's moving at a speed c, and naturally the photon will be at rest here. You can see this velocity u prime equal to 0. Similarly, the electron, which is in purple here, so this is moving at 0.85 c in the frame S, the rest frame, while in the photon frame it will be moving at some speed ux prime. No, I have denoted electron as electron prime because everything is primed in this frame. The velocity also will become ux primed. So what we need to find is the velocity of this electron with respect to photon. That means velocity of electron in this s prime frame, which we typically denote by the symbol ux prime. And we note that we know the velocity of velocity of electron in s frame, which we usually denote by the entity ux. So we know ux is 0.85 c. So how do we obtain ux prime if you already know ux? This is a very straightforward formula which we saw in a couple of slides back. This is the formula. So I can just simply plug in the values. Note that ux prime is velocity of electron with respect to the photon frame, the s prime frame, and ux is velocity of electron in s frame. So ux is given as 0.85 c. Now what is v? V is the velocity of moving frame, which is c, because this is the frame of photon, divided by 1 minus, this will be 0.85 c times c over c squared. So this gets cancelled. We get minus 0.15 c over 1 minus 0.85. This will be minus 0.15 c over 0.15. This will come out to be minus c. This is very interesting because this photon will see this electron moving in negative x direction at speed of light, which makes sense actually. If you're sitting on photon, so everything will move, will seem to move away from you at the speed of light, which this negative sign denotes it's moving away, and c is the speed of light. So what we obtain is that the minus c. So option B is the correct one. Only one option correct. So that's all. Thank you for listening.